Well, hello, friends. Marcus D coming at you all with another brand new video that I'm producing for the Great Questions group. And today I'm bringing to you part 4 in my new series on science. And for those of you that are checking this out, if you'd like to find the other videos that I have, they are posted on YouTube. But if you want a little more information on the Great Questions group, some of the other materials that I've produced, and these videos in order, you can find them all posted on my website. You can just go to greatquestionsgroup.org, which will take you to the About page, and then you can navigate wherever you'd like to go. Everything's listed on there. And yeah, that's probably the simplest way to actually find them, along with I've got some classic audios on there as well, and some written material, and I continue to add to it. So anyway, just wanted to mention that to you. But today we're going to be talking about the law of probability, all right? And what I want to do is I have some things I want to read to you from some scientists that study this topic, all right? And what this is also going to do is it's going to bear out once again that all of us on a fundamental level, on a basic level at least, are scientists because we know the way the world works, all right? And when we start talking about probability, again, keeping these things simple, we know that if we take a coin and we flip it, all right, the odds of getting heads over and over and over again are very, very slim, all right? And so what we want to do, and what scientists have done, is they've taken a look at the complexity of life in the light of probability, all right? And what I've got here is I've got some notes. I receive information from a lot of different people, and this is actually a couple of pages of notes that I actually received from a creation organization in Texas that I've sort of been affiliated with for a long time. I know the founder and director. It's it's called the Creation Evidence Museum, and I've supported it over the years. But anyway, they send out this information, and it's interesting because it kind of ties into something that I've been thinking about that's been on my mind. You know, folks, one of the interesting things about this, and again, as I've shared with you on many occasions, I'm sharing with you my journey. All right. I didn't set out to be a teacher, okay? I set out to make sure that I had my future in order. Even though I have been a teacher, I've been a life coach, I've been a small business owner, and as many of you know, the business, the networking that I was a part of and still am a part of, not as extensively as I used to, but still own a small network. But a whole bunch of that was about life coaching, enhancing people's understanding of reality and their happiness, and just their ability to function in the world in which we live in. And that's what I wanted to be able to do. And so why all this is important is because these are things, folks, the reality, the great questions. This is not some just cool little thing. These great questions are questions that are going to impact all of us, and in particular our destiny. And I wanted to know if there was something better than this reality, all right? I've shared that on multiple occasions through these videos, but I keep thinking about that all along because let me just share this with you. I've studied this for a long time. I've pursued a relationship with this living God for a long time. And the interesting thing is he helps us, and he continues to open up my mind more and more to a deeper appreciation for what's really real. And what's really real is this life is setting the stage for the next one. And the more I learn about these things, and the more I see how the created realm reflects the necessity of God, it increases my faith. It anchors me in my beliefs. And I know that I'm not pretending, all right? It just makes all of these things more and more real. And so, that's why this is important for those of us that, any really thinking person. Because again, folks, nobody's here forever, all right? This is a temporary journey. So what I want to do is I want to set the stage for you folks as we get into this in this particular video, because there's going to be two particular things that these quotes are going to refer to. And we've talked a little bit about the complexity of living systems, that the knowledge of this complexity has exploded in the last number of years. And what has happened is scientists that know how to calculate these probabilities have taken a look, taking, again, the probability law, which is pretty hard and fast. Like I said, we know how many times if we flip a coin, the odds are 50-50, and we know what the improbability is of successively just keep flipping a heads and a heads and a heads, okay? And so what I want to do, first of all, is I want to basically give you guys just a very, very simple overview of a few basic things that are going on in the cell, because that's what they're going to be referring to here, okay? They're going to be talking about the odds or the probability of even a very simple cell, okay, coming into existence by itself in the light of the known laws of chemistry and in the known laws of probability, all right? So the first thing I want to basically just share with you quickly is within a cell or the cell itself, there are main molecules. The primary building block of a cell are protein molecules, all right? And again, I want to keep this very, very simple. And proteins are made up of amino acids, all right? Amino acids are molecular compounds. They're made up of particular components. They're made up of atoms, basically, all right? Again, I want to keep this really simple. They're biochemical compounds. And so what we have is we have atoms, all right, that make up these molecules. And these basic amino acids have multiple parts to them. But then what happens, the way a cell makes a protein, all right, is these amino acids, and there are 20 amino acids that biological systems use, all right? 9 of them, the body, I know in human beings anyway, the body does not produce itself, and those are the things we have to eat, all right? The other ones, the body is able to synthesize itself. The cells are, all right? But just again, keeping this very simple. What the cell does, all right, is the cell takes these amino acids and links them together in a very, very specific pattern. How does it do that? Well, it does it basically with the DNA. All right, the DNA is the code, the programming code, the instructions within the cell that tells the cell how to manufacture specific proteins, because the entire structure of the cell, for the most part, is all made up of all these different proteins, all right? And there's many, many kinds of them. I'm going to refer to some of this as I go through this with you. All right, so these amino acids, what has to happen is these amino acids have to be connected, all right? And they have to be connected in a very, very specific way. What happens in the cell is the DNA, which is coiled up, is unwound, all right? And then these molecular machines come in and they copy, all right, the DNA. They copy the letters of the DNA. And then based on, it's another, they call it RNA, messenger RNA. So the messenger RNA comes in, it copies the section of the DNA that codes, as they say, for this particular protein. And then that messenger RNA goes over. And then what it does, and this is all these little molecular machines going on inside individual cells, all right? In every living system on Earth, it's really quite profound. And then this messenger RNA within the cell has these amino acids line up, okay, according to the plan in a specific chain, as it will, a long chain, all right? And then what happens is, and some of these chains can be, quite long, all right? And you're talking hundreds of amino acids. And then what happens, so you got this long chain of amino acids, and then there are these other machines that come in, and then they take this chain and they bring it into another molecular machine inside the cell. And then what happens is, if the chain is formed properly, it will actually fold into a three-dimensional, quote, building block, if you will, for a particular piece within the cell that, where it needs to go, the part it needs to replace, or the part of the cell that it's constructing, right? If it's something that's being created for the first time. Folks, that process is extremely complex. Let me just say this to you. Amino acids, all right, do not form randomly by themselves. Scientists, by using very, very controlled mechanisms, okay, in laboratories, putting a certain type of concoction together and then electrifying it and electrifying this solution, actually have had some of the amino acids actually come together. But not all of them are able to be used in biological systems. And if they don't control that environment, they will immediately fly apart. The chemical bonds are not normal bonds, all right? So they have to be kind of artificially forced to happen, all right? Now let me tell you something else when we were talking about flipping the coins. The amino acids have shapes even of themselves, all right? And scientists use a fancy term, it's called chirality, but what it really means is right-handed and left-handed. They have two shapes. It's kind of almost like flipping a coin. When they form, they'll form either with right-handed or left-handed, all right? But what's interesting is, folks, in biological systems, all right, the amino acids and proteins are exclusively left-handed amino acids, which is a statistical, highly improbable, all right? And that's what these guys are referring to. They calculate all this stuff, and then they start showing you these odds, all right, of really, is it really possible that life could have just spontaneously happened? All right. So these are some of the things that what they're going to be talking about is could a single protein form without any kind of a code, without any kind of a mechanism? And they're starting to calculate this. All right. Now, what else they're going to be talking about is powers of 10. All right. And this is something that I just want to mention to you very, very quickly. It's when you take and they call these exponents too. When you say 10 to the 10th power or 10 to the 20th power. All right, folks, when you start using exponential numbers or exponents, you start, you tend, as I was just saying, 10 to the 5th power. And again, what it means is you're taking 10s and you're multiplying them again times 10, 10 times 10 times 10 times 10 times 10. Folks, when you start doing that, the numbers get huge because, again, every time you add one more zero, one more multiplication, you're taking the previous number and multiplying it times 10. So each time another zero is added, it's double. It's not doubling. It's 10. It's multiplying times 10 the previous number. To just kind of illustrate that, many of you remember the old penny a day doubled thing. All right, how if you took a penny and you doubled it every day, all right, for a year. As a matter of fact, I came up with a chart, and I'm going to read you just a couple of quick things. Not a year. I'm getting it. A month. You take a penny, you double it every day for a month, and at the end, all right, you end up with, if you did that. Now it's really kind of interesting. If you did that, by day 9, you have. Let me put my glasses on here. By day 9, you have $2.56. Okay. By day 15, halfway through the month, you have $163.84. All right. By day 20, you have $5,242. All right. And this is just taking the penny a day and doubling it. All right. Doubling it. By the time you get to day 30, though, you have $5,368,709.12. All right. By doing that. But let's take that same analogy and let's do it times factors of 10. Not just taking the penny a day, doubling it, taking the penny and multiplying it times 10 each day. I did some checking. The entire wealth of the world is right around, if these figures are correct, I checked it on Yahoo, is $1.5 quadrillion. All right? So that's a quadrillion is 1,000 trillions, which is 1 trillion is 1,000 billions, all right? And on it goes, all right? But the entire wealth of the world is estimated at $1.5 quadrillion, all right? Now, here's what's crazy. If you took a penny and started multiplying it times 10, by the time you got to day 20, you would have $1 quintillion. Way more than all the wealth of the world. That's how powerful these factors of 10 are. And so when I start sharing some of this with you and what these scientists are saying, the odds are unbelievable. As a matter of fact, when I was reading through this, I was like, wow, okay. And you know, what's interesting is they're going to, one of these scientists is actually going to refer to something that I've actually been thinking about, all right? And I'll get to that at the end, all right? Because it just, you know, as I think more and more about these bodies that we live in and how could they possibly have just assembled themselves, all right? I mean, it's crazy. So what I want to do is I want to read you a few things here. And listen, one other thing I want to mention to you too. Now, because when I was thinking about the powers of 10, it brought something to mind. I saw a video years and years ago, right? And I think it was produced in 1977. And it's actually called The Powers of 10. And it's actually, for its time, it's a pretty well done video. It's 9 minutes long. I found it online. I'm going to attach it here so you guys can check it out. And what's really cool is it starts off and it starts going from, well, you'll see, there's a couple people there. And what it does is it goes outward into the universe. And the thing is, back in 1977, they didn't realize that the universe was 20 billion light years across, as they were thinking. Is it 200 billion light years across? 20 billion light years across. They think it was 10 billion, so they didn't know with the Hubble and everything else. And now we know it's expanding. And what's crazy is it's expanding faster than the speed of light. So that's another interesting thing that's kind of flying in the face of the Big Bang. Okay, how explosions don't accelerate? All right, that's why they postulated all this black matter. They're trying to come up with this dark matter. There's got to be something out there pulling it. Well, it's all conjecture. All right, how can the universe be actually, accelerating while it's expanding? All right, something else has to be at work there. All right, which is really pretty amazing to think about, even with that. But anyway, what it does is it goes all the way out to the end of the known universe in factors of 10, and then it goes all the way down into the nucleus of an atom. If you've listened to some of the videos I've done on atoms and things like that, in the universe and the size of the universe and all of that, it's going to resonate with you. And it was one of the things when I saw it long time ago, I was like, wow, this is crazy. What's really going on here with all this? The sizes, and again, there's a parallel between the very, very small and the very, very large. When he shows you the atom and how much empty space is in the atom itself. But here's what I want you to understand when I start going through these numbers. When you watch that video, all the way down to the smallest little proton, all right, all the way out to the most distant galaxy, okay, is 40 powers of 10. All right, 40 powers of 10. Taking 10 and multiplying it by itself 40 times takes you all the way out to the known universe. Well, Mark, it's 20 billion, not 10 billion. Just add 1 0. That's all you have to do. That's the power of 10. If it's 10, instead of 10 billion, you add one more 0, it's 20 billion. Actually, it's not. It's more than that. Okay, all you have to do is double the 10 billion, not multiply it times 10. Then it'd be 100 billion light years. I mean, again, that's the factor. So all the way down from the smallest thing we know out to the biggest thing we know is only 40 factors of 10. All right. Now I want to read you some of this stuff. All right. And because again, I'm like, this is just amazing. And again, I love learning about this stuff. And that's why I want to share it with those of you too that do. All right. And a matter of fact, the first guy I'm going to quote here that they've quoted is somebody that I quoted before, an astronomer by the name of Fred Hoyle. And I'm going to actually read you something out of one of my little quote books here by him. All right. The odds of a complex molecule. All right. And these are biological molecules. And again, what he's talking about here, he calls them in this case a biopolymer. All right. And he's talking like a protein. All right. As a matter of fact, I think he says it right in here, i.e. large molecules. So let's slow down here. Okay. Noted astronomer Fred Hoyle uses the Rubik's Cube to illustrate the odds of getting a single molecule, in this case, a biopolymer. Biopolymers are biological polymers, i.e. large molecules such as nucleic acids or proteins. In the fascinating illustration below, he calls the idea of chance, that chance could originate a biopolymer nonsense of a high order. Anyone ever, with even a nodding acquaintance, now that we're quoting him, even a nodding acquaintance, and again, this information was assembled by two individuals, Dr. John Ankerberg and Dr. John Weldon, who are associated with this organization, all right? Okay, so again, these are all scientists or people that are quite knowledgeable in these arenas, all right? So again, anyone with even a nodding acquaintance with the Rubik's Cube will conclude the near impossibility of a solution being obtained by a blind person moving the cubic faces at random. All right, now we're going to start getting into some of these powers of 10. Now imagine 10 to the 50th blind persons. Okay, so I just mentioned to you, okay, I mean, how much money, all right, when we started talking about, so now we're talking about 10 multiplied by itself 50 times, all right, 50 times, 10 times 10, and again, you got to remember, so it gets larger and larger by factors of 10. The previous number is multiplied by 10, the previous number is multiplied by 10. So these numbers are huge, blind persons, all right? Each with a scrambled Rubik's Cube, and try to conceive of the chance of them all simultaneously arriving at the solved form. You then have the chance of arriving by random shuffling at just one of the many biopolymers on which, just one, that life depends. The notion that not only biopolymers, but the operating program of all living cells could be arrived at by chance in a primordial organic soup here on Earth is evidently nonsense of a high order, the highest order. All right. And what's interesting is he goes. I'm going to refer to him a little later. Let me share something out of one of these little quote books. This is by him also, English astronomer, professor of astronomy, Cambridge University. Okay, as quoted in Hoyle on Evolution. All right, November 1981. And remember, if you say, well, 1981, remember, Darwin's book was written in 1859, folks. All right, 1859. I mean, what we knew back in 1850, well, you just kind of figured out, right? We didn't know anything like we do now. Listen to this. The chance that higher life forms might have emerged in this way, again, talking about just blind chance, is comparable to the chance of a tornado sweeping through a junkyard might assemble a Boeing 747 from the materials within. Okay, y'all know what a jumbo jet, big jumbo jet. So just a tornado flying through a junkyard, boom, out the other side pops a 747. And you want to know what's really crazy is there's greater chance of that happening than some of this. Okay, this happening. So let's go on. Let me read you a few of these because these numbers start to get crazy here. Okay, 40 years ago, scientist Harold F. Blum, writing in Time's Arrow in Evolution, wrote that the spontaneous formation of a polypeptide of the size of the smallest known protein seems beyond all probability. And again, I'm just going to read through some of these things. Noted creation scientists Walter L. Bradley and Charles Thaxton, authors of The Mystery of Life's Origin, Reassessing Current Theories, points out that the probability of assembling the amino acid building blocks into a functional protein is approximately one chance in 4.9 times 10 to the 191th power. So that's 4.9 times 10 multiplied by 191 zeros after time. Folks, okay, that is, I'm going to go through some other numbers here, and you're going to see this is, and I haven't even got to the good stuff yet, all right? Such improbabilities have led essentially all scientists who work in the field to reject random accidental assembly or fortuitous good luck as an explanation of how life began. Now listen to this. Now, if a figure as small as 5 chances in 10 to the 191th powers is referenced by such a statement, then what are we to make of the kinds of probabilities listed below that are infinitely less? The mind simply boggles at the remarkable faith of the materialist, because the numbers that we're going to get into here right now are even crazier. Listen to this, okay? Consider that the smallest theoretical cell is made up of 239 proteins. Further, at least 124 different types of protein are needed for the cell to become a living thing. But the simplest known self-reproducing organism, and then it goes to name this H39 strain of PPLO. I don't know what but listen to this, okay? So this is the simplest, quote, simplest known self-reproducing organism, contains 629 proteins with an average of 400 amino acids in each protein. Remember I was telling you about the little building blocks? Okay, they're all left-handed, so you had to flip the coin. Now, in this case, just left-handed, right-handed, they're all left-handed. And there's another part in the and I believe it's the actual chemical letters in the DNA that are all they form two ways, the same basic thing, and they're all right-handed. So you got one part of the cell that's made up of all left-handed stuff, so you flip the coin over and over and over again, get all heads 400 times. Just that itself is a statistical monstrosity, all right? 625 proteins, but then you've got to get them all lined up properly. And then they all have to be folded properly. And then they all have to be put in just one, they all have to be functional at the same time. There's another concept that scientists use all the time. It's called irreducible complexity. It means the cell has to be in place, fully functional to be viable. Otherwise, it all flies apart because the chemical bonds inside the cell don't naturally occur. The complexity that's in the cell doesn't naturally occur. The information in the DNA code does not naturally occur. The molecular machinery does not naturally occur, those functioning machines that are in there. I'm going to be getting some videos to you as we go through this. Little videos here and there that you can actually look at and just get a chance to get an idea of what some of these machines are like. And folks, it's astounding. All right. So let me read you. Let's go back to Sir Fred Hoyle here. In the 1970s, Sir Frederick Hoyle calculated the mathematical probability that a single bacterium could be spontaneously generated. Listen to this. He determined the chance of this occurring was 1 in 10 to the 40,000th power. You get that? 1 times 10, not to the 191th, to the 40,000th power. And it gets better than that, all right? Now, I'll read you a couple other things. He confessed what most scientists are strangely unwilling to confess. Quote, the likelihood of the formation of life from inanimate matter is 1 to a number with 40,000 noughts, zeros after it. It is enough to bury Darwin and the whole theory of evolution. There was no primordial soup, neither on this planet or any other. And if the beginnings of life were not random, they must therefore have been the product of purposeful intelligence. Now, this is going to get even crazier, all right? Another gentleman, Harold Morowitz, a Yale University physicist, gave a far more astounding probability, actually it says realistic probability, for a single bacterium. He calculated the odds of a single bacterium emerging from the basic building blocks necessary were 1 chance in 10. Are you ready to, I mean, this is just insane. 1 chance in 10 to the 100 billion. That's 100 billion. 100 billion. 1 chance in 10 to the 100 billionth power. This number is so large, it would require a library of approximately 100,000 books just to write it out. Oh, it's crazy. All right, now, let me just get back. Let me kind of wrap this up. I want to talk about 2 other huge numbers that these guys talk about, which is just amazing stuff. So, I mean, folks, I'm going to read you some quotes at the end here. And, again, as I've said over and over again, look, well, let me finish this up. All right. Now what we're going to talk about are very large numbers, impossible, as if those weren't large enough. Okay. I don't know how you get much larger than those. They're inconceivably large. But I want to relate some of these things to you. Okay. This is something that I thought was kind of interesting. Again, these numbers are unimaginable. That is why scientists don't know what to do with them. Consider that a given individual, now this is something, consider that a given individual's chance of winning the state lottery is about 1 in 10 million. The odds of winning each successive week involve the multiplication of probabilities. So the odds of winning the lottery every single week of your life from the age of 18 to 99 is a period of 81 years is one chance in 4.6 times 10 to the 29,120th power. In other words, it is infinitely more likely that you would win the lottery every week of your life consecutively from the day you were born without missing even one winning weekly ticket for 81 years than we would have the spontaneous generation of a simple bacterium. And remember, spontaneous generation. Do you remember in one of the previous videos, I think the introduction, I talked to you about that theory, spontaneous generation, that was disproven. It's still disproven. So what does time have to do with disproving spontaneous generation? As a matter of fact, time makes it worse, as we talked about, because time's arrow, the law of decay, the more time there is, the worse it gets. All right? It's just amazing. Now, let me talk to you. We're going to talk about something called a googol, not Google, but a googol, Googols, these mathematicians came up with, which is basically 10 to the 100th power. And then something called a factorial, which is just crazy, all right? But I want you to hear this because I want to draw a couple of little comparisons here, all right, to some of the things they're talking about. Okay, physicist Dr. Howard B. Holroyd refers to the book Mathematics and the Imagination, where authors Kasner and Newman named the extremely large number 10 to the 100th power a googol. Okay, a googol. So 10 to the 100th power. Now listen to this. Noting the fact that there could only, at most, have been 4.8 times 10 to the 38th, only 38th, now we're talking hundreds, we were talking thousands, we were talking billions powers, okay? 4.8 to the 38th power, possible mutations in all life forms throughout the history of the earth. Okay, that's still a huge number, but not compared to what the odds are of any one of these things happening by chance. So all the mutations of all the life forms over the entire, even if you postulate 4.6 billion years, are not enough times for the mutations to even create one amino acid by itself, let alone a protein or an amino acid chain. And then you have to have it in the right order, like I said, and then you have to have the mechanism to fold it. And then you have to have all that going on to put all the building blocks together to form a cell, just one cell. And where does the information come from that's inside the cell? All right. Dr. Holroyd writes, it is not possible in a gogol of operations. Now, here's the thing that I wanted to mention. And this is, because I've been thinking about this, folks. I've been thinking about this. Dr. Holroyd writes, it is not possible in a gogol of operations to select at random from the possible infinity of forms the shapes and arrangements of the dextral and sinistral bones of even one mammal. All right, now, I didn't know what dextral and sinistral was. I was like, I think I might have an idea. But it gets back to its handedness. Okay, it's what the biochemist calls chirality. That's another big word. But it's just right and left-handed handedness. All right, now, what's interesting, and I've been thinking about this. Folks, do you realize, all right, we have, this is kind of a no-brainer, we have a right arm and a left arm. Do you realize we would have had, in order, and we just kind of take it for granted, we've got a right leg and a left leg, all right? Do you realize we would have had to evolve two identical arms and not only evolve, we just say, well, we got one on the left, one, we would have had to evolve, all the muscles, all the bones, all of this, okay? And then we would have had, what if we had two right arms? We had a right arm on this side and the palm was facing out that way. No, we got right-handed and left-handed, all right? So we got one on one side, one on the other side. And that's not even talking about all the things that are going on, to do that, the bones. And this is what he's talking about here. In order to lay out just the bones, the right-handed bones on a mammal, and all mammals have this. You got the wings of a bird. You got the legs in a horse. You got the legs in a dog or a cat, okay? You've got to have a right-handed one and a left-handed one. And what he's talking about is the odds of that happening here. All right? And the infinite possibilities of that happening. You know, folks, let me point one other thing out to you that's really been hitting me lately, is our teeth. I mean, do you realize, you know, again, we would have had to evolve, okay? I mean, what is it? I looked up the statistics. I'm going to go back and check my notes real quick because I wrote this out. I think kids have 20 teeth on average. And then they all fall out, and then as adults, most of us have 32. I originally had 32 because the last four molars, they call them the third molars. They're also called wisdom teeth. Most of you probably know about them. I know about mine because I have all mine cut out because they were all laying sideways. Oh, what a deal that was. Okay, they were anyway. But folks, do you realize? Okay, we would have had to. You talk about the teeth. We would have to evolve the proper kind. Not only the enamel, not only the dentine that's inside, not only the blood flow, but the identical shapes and in the right position. Okay, the molars in the back and molars on the bottom and the jaw and what all white. Okay, and all the proper shapes. You know, the incisors and then the first incisors, second incisors. Then they have the cuspids and then they have the first molar, second molar, third molar, like we were talking about, and all these and again the proper shapes on the top and on the bottom. And then the sets, when you're a kid, the first ones come out and then they fall out and then the new ones come up. I mean, I was thinking about that, like, wow, wait a minute. Okay, how does that happen? All right, each one of these things, when you start looking, that's not, I mean, 2 eyes, 2 ears on the same side. I'm going to talk a little bit about that as I wrap this up, okay? The connections, which is absolutely crazy. But when he said this, I'm like, oh my gosh, he's talking about, and it's been on my mind. Why? Because look, folks, let me tell you what happens. As we start getting interested in this stuff, this God who's real, who created our mind, who's sustaining our mind, who knows our thoughts, we've talked about it, he starts teaching us. He starts opening up our minds to these things. He goes, hey, let me point this out to you. I mean, it's amazing how much my eyes have been opened as I've been on this journey. That's why I keep doing it. Okay? I want to set myself up. I want to set myself up for that new reality, folks. Okay? I want to max it out. All right? This is the whole 9 yards. All right, there's no greater game than this, if you want to call it that. There's no greater investment than this. All right, and it honors our God when we want to know these things. All right, and as I said, because He's there. All right, that's not. It's still a statement of faith, but backed up by so much evidence now, and we're talking about more of it. All right, and so I know this is not a vain thing that we do, as the Scripture says. It's our very life. It's our eternal life. All right, because everything in this life is fading away, as we well know. All right, and so what he was talking about. Let us recognize that if the result depends upon 100 factors, and if the probability of getting each one right is 1 in 10, then the probability of getting the whole 100 right is only 1 in a go-go. Okay, 10 times 10 to the 100th power, which again is infinitely greater than all the possible mutations that we could have ever had in here. All right, let's talk about one last one here. Okay. I don't even know how long this is, but again, if you want to listen, you can, and if not, you don't have to. All right. But I hope you're interested in this stuff. That's why I'm producing it, and I apologize if some of these are longer, but it's okay. All right. I've listened to some really, really long lectures. Come back, listen to the second half, listen to the third half, or whatever. Okay. Dr. Holroyd also discusses factorial numbers. Factorial numbers. A factorial number is a number that multiplies each successive number by the next number. So these are even crazier than powers of 10. Why? Because what he's talking about is a 10 factorial would be to multiply 1 times 2 times 3 times 4 times 5 times et cetera, times 10. So if you had a 20 factorial, you'd multiply then 10 times 11 times. So each number is getting larger. You're multiplying it times even a larger number. It's not just by 10, by 10, by 10. You're doing it by, so by the time you've got a 50 factor, you're multiplying the 49th one times 50-fold. And then up to 100, et cetera, et cetera. Now listen to this. All right? And this is because this is the last thing I'm going to do, except I want to read you these couple little short quotes, and then we'll be done. 70 factorial would be around a gogol, which is 1.198 times 10 to the 100th power. Listen to this. Sir Arthur Eddington, all right? He was a great physicist too, I believe, all right? But I've certainly heard his name. Estimated that the total number, listen to this, of electrons and protons in the entire universe as approximately 3.145 times 10 to the 79th power. All right, I mean, do you get that? I mean, the total number of electrons and protons, we're talking, again, the atoms. So we're, in the entire known universe is only, let's call it 3.2 times 10 to the 79th power. Because that's how big 10, just 10 to the 79th power, let alone these other crazy numbers that people have been talking about here. That's, I mean, it's mind-blowing. This is infinitely less than 100 factorial. Infinitely less than 100 factorial, which equals 9.3 times 10 to the 157th power. Okay, that's still tiny, 100 compared to the numbers we've been talking about. But when it comes to evolution, we are not dealing with 100 factorial. But listen to this. But when it comes to evolution, we are not dealing with 100 factorial, but millions times millions factorial. To illustrate, there are 5,000 fibers in the auditory nerve of man that may be connected to the brain in 5,000 factorial ways. 5,000 factorial ways, and probably only one is correct. Look, folks, I remember looking online, you can do this, at the structure of the inner ear of man, all right? And the organ, and again, I can't remember the name of it right now, but it looks like the snail. Okay, you got the little eardrum, and you got the little tiny bones, and the final bone is attached to this little membrane on this, and you've got this one organ that looks like kind of like a snail shell, and then you have this other organ that is three-dimensional. It's got a loop like this, a loop like that, and a loop the other way, and that's the one, and that one has got fluid in it. And it's got all these little hairs, and that's the one, it's like a gyro almost, and that's what gives us our balance. That's what lets us know, whoa, we go like this because the fluid moves, the hairs move, and all those little hairs, every single one of them is attached to a nerve. Okay? And all those nerves, and that's just for our little balance organ, all right? Then there's the one that's the curved one, all right, that has all the audio little hair. There's fluid in that one also. And there's little audio hairs in there. And they go from thick, okay, long ones down to small, like pipe organs, folks. Like the pipes in an organ, the really big ones. And look, folks, every one of them is tied to a nerve. And anytime the little bones from the eardrum go in there, and they're attached to the little membrane on that little guy, and he's wobbling back and forth, and it moves that fluid. And however the frequency is, all those little hairs move and pick up the particular frequency of what's being transmitted. And every one of those hairs, those 5,000 hairs is what it's saying here, okay? Those 5,000 little fibers, all right, are all tied to a nerve. And folks, if you look at the structure of that, it looks like the computer system or a professionally installed electrical system in a home or a building where all of the wires are in each section. They're all bundled. All right, they're bound together, and then they're brought into another cable, into another cable, into another cable, and then they're bundled all together, and then that cable goes into the brain. And like they're talking about here, it doesn't just plug in somewhere. No, every one of those 5,000 fibers is attached to a portion of the brain where it's supposed to be, so that even you and I now, I can hear myself, my voice, you can, through this electronic stuff, the speaker or whatever you're listening to, those sounds are going through that system and going into your mind and allowing you to process it, like all of us, me to process it, you to process it. Okay, to make out of those sound waves, okay, to translate those sound waves into intelligent information. It's a marvel, folks. It's an absolute marvel. Now, let's just go one step further. So they're talking about 5,000 factorials just for the audio. Let's go to the eye now. Because the eye has the exact same thing, except it's that much more complex. You're talking about 1 million nerve endings. We got 1 million rods and cones in each eye that are living cells. specifically designed cells, one kind designed to pick up color, the other one's designed to pick up black and white. You know what else is interesting? Okay, it takes less light energy for the black and white ones to fire than it does the color ones. That's why when it starts getting dim, we lose our color sight. We start to see in black and whites because the color ones don't fire anymore. But each one of those is tied to a nerve, and it's this exact same thing. All right, and if I even told you, okay, the biochemical cascade of events that has to happen to take a photon hitting the front of the retina to create an electrical impulse that can actually go to that nerve, all the steps that have to happen lightning fast over and over again. I got a book called Darwin's Black Box, this biochemist who studied all this stuff. It would blow you away. It blew me away. I'm like, are you kidding me? Just so that you and I can see. But the exact same thing happens. But now we got 1 million, and they're all, again, same thing, like a complex, highly sophisticated electrical wiring system. That's what it is, by the master designer. And then that attaches, the optic nerve goes into the mind. All right? And now we're talking, now listen to this one, okay? The optic nerve has about 1 million fibers. 1 million nerve fibers. These may be connected to the brain in listen to this, 1 million factorial ways. Okay? 1 times 2 times 3 times 4 times, all the way out to 1 million times. So you've got 900,999 times 1 million after you've done all those numbers. And that's way bigger than that because the number, anyway, it's just, folks, okay, it's off the chain is what it is, all right? And he says, the odds that they could have been connected correctly by chance cannot even be written. Cannot even be conceived of. Holroyd proceeds to show this and through a bunch of other examples how absurd the belief in chance evolution is, all right? A couple of quotes. And this is from one of my quote books here. This first one, Professor Louis Bonheur, former president of the Biological Society of Strasbourg and the director of the Strasbourg Zoological Museum, later director of research at the French National Center of Scientific Research, as quoted in The Advocate Thursday, 8 March 1984. Evolution is a fairy tale for grown-ups. The theory has helped nothing in the progress of science. It is useless. Here's another one. Okay, this is by Dr. T.N. Tashmizian, Atomic Energy Commission, USA, in the Fresno Bee, August 20th, 1959, as quoted by N.J. Mitchell, Evolution and the Emperor's New Clothes, Royden Publications, UK, 1983, title page. Listen to this. Scientists who go about teaching that evolution is a fact of life are great con men. And the story they are telling may be the greatest hoax ever. In explaining evolution, we do not have one iota of fact. And here's one other one. Malcolm Muggeridge, world-famous journalist and philosopher. Pascal Lectures, University of Waterloo, Ontario, Canada. I myself am convinced that the theory of evolution, especially to the extent to which it has been applied, will be one of the great jokes in the history books of the future. Posterity will marvel that so very flimsy and dubious a hypothesis could be accepted with the incredible credulity that it has. And in case you're wondering about credulity, the tendency to be too ready to believe that something is real or true. Readiness or willingness to believe, especially on slight or uncertain evidence. Willingness to believe or trust too readily, especially without proper or adequate evidence. Gullibility. The irony is, that's what I was told that those of us that believed in special creation were. We were gullible. We were, believing incredulity. All right. But the fact is, folks, it's the exact opposite. You have to have far, 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 far more faith in the impossibility that these complex living systems could have formed themselves. There really is a God, all right? And he not only created all of us, folks, but when you really look at the evidence, as I said in those great Questions Quest lectures that I've done, those videos, he's now sustaining us. He's sustaining every atom. He's sustaining, every organ every cell, every molecule, every atom in every living system on this planet, and every the structure of every non-living system out to the most distant star, galaxy, whatever's out there, however far it is. Scientifically, he must be. Okay, there must be a mind behind all of that, and that's what all the real science points to. So anyway, I know I've set a record. This is by far the longest video I've ever done. But anyway, folks, I'm doing this because, I want to share this information with those of you that are interested. And I've certainly heard lectures way longer than 50 minutes. So, again, and this is a labor of love, I'm not charging you for any of these. I welcome any donation support that anybody's led to provide or help out with, but you don't even need to do that if you don't want to. I'm doing this, like I said, because it's in my heart. And, to whom much is given, much is required. There's a responsibility there to pass it on. And folks, we all want to be set up for that future, which is coming. And I'll just say this in closing. Look, if there really is a God who's responsible for all this, what can't he do? And those promises that are in his word about the reality that's coming and how great it's going to be, we're really going to experience one day. For those of us that know Christ, that love him, that are trying to honor him with this brief, willing to invest some of this life, not just spend it on ourselves, indulging ourselves in everything, just me, myself, and I, but no, really learning really, folks, learn to live for others, learn to honor him. We're setting ourselves up for that eternity, and it's like I said, it's going to be beyond our wildest dreams. So that's part of the reason why I want to do this too, because I'm excited about that reality. Okay, I wanted something better than just this life. I wanted something permanent. I wanted something transcendent, and there really is something there, way beyond this one. And so anyway, I wanted to share this with you. I want to pray that each of you, will continue to grow and understand these things and appreciate them that much more, and honor our great God because of it. All righty. God bless you guys. Until next time, Marcus T signing off, wishing you all a wonder-filled day. Okay, bye-bye now.